Okay, so what is slope? Well, we have 3 bullet points that we're going to talk about what slope is. Well, first of all, it's constant, which means it doesn't change. And the way you know slope doesn't change is you have a straight line. No matter which way it's facing, no matter how it's angling, as long as you have a straight line, you know that the slope is constant, which means it never changes. Or we'll say stays the same. So we say it's the constant rate of change between 2 points on a line. And this word change, we use the Greek letter delta, which means change, okay? Now, anytime you see, well, we're going to talk more about this Greek letter delta, and it'll help you remember the slope formula between 2 points really easily, okay? So just look forward to that in the next lesson. Okay, it's also a ratio, and by the way, anytime you see the word ratio, I want you to think fraction, not just the semicolon. A lot of people will only look at the semicolon or the, like, if it's 5 to 11, you can use the word 2 or the semicolon, or it could be 5 over 11. So ratio, we're going to write all slope as fractions, okay? So it's going to be the ratio of the rise to the run, and rise is vertical, and we're going to say vertical change, or delta. Oh, did I say this Greek letter delta means change, right? And run is the horizontal change. And so I just write it as horizontal with the delta symbol. So it's the horizontal change. Now the variable that we're going to use from here on out that represents slope is m. Okay, now when we classify the slopes, there's 4 types of slope, and this is how you classify them. And the only way to classify is we have to do it from left to right. Okay, so it must be from left to right. Later we'll learn how to, or in these notes, you'll learn how to count slope in both directions, from left to right and right to left. But when you're classifying slope or determining which type of slope it is, it's always from left to right. So in this case, you see the line and this little skiing penguin going up the hill, right? So since it's from left to right going up or increasing, then we say it's a positive slope. And then this line, it would be like a downhill ski slope, and you can see that it's from left to right decreasing. So anytime a line will decrease from left to right, it's going to have a negative slope. Now, we know this is a horizontal line, but the thing I want you to really understand is it has 0 rise. In other words, there's 0 vertical change. There's 0 up or down. So if we have 0 rise, and then we can run the 2 arrows on both sides as much as we want, there's infinite run. And run is horizontal change, okay? So if you have 0 up and down, and you can run left or right as much as you want, the overall slope is going to be 0, okay? And we're going to talk about how you can use an acronym to really help you remember that horizontal lines always have 0 slope, and how to use that in equations and a whole lot of other stuff in the next few lessons. So stay tuned for that. Now, this one we know is vertical, and well, the vertical change, we can go up or down as much as we want. So I'm going to say infinite rise, but there's no left or right, so there's 0 run. Well, if you remember from elementary, the difference between these two ratios, 0 divided by some number or some number divided by 0, you can divide 0 into anything and it equals 0. But you cannot divide any number into 0 because there's nothing to divide 0. There's no groups you can make. So this is no solution, or you can call it empty set, or you can say that there's no slope. Okay? And we're going to talk about that some more. There's, like I said, there's an acronym for vertical lines and there's an acronym for horizontal lines that help you remember what slope is which so you don't get them confused, and how to write their equations, which we're going to get to in the next few lessons. All right, so finding slope. First thing, you could quickly go through and say, okay, well, I know this is going to be positive. I know this is going to be negative. Well, horizontal, remember we said horizontal has a 0 slope? So we say that all you have to do is say the m equals 0 because we know that it's a horizontal line. 0 because we know that it's a horizontal line. Now, we're going to come back to these because the only reason why I go through quickly is sometimes people will count the rise and the run, which I'm going to show you in a minute, but they forget to put the final answer with the correct sign. So that's why I like to go through and say, okay, if it's not horizontal or vertical, you can quickly determine, oh, well, the final answer is going to be positive since those, like in 5 and 6, because the line is going to go increasing from left to right. And number 2, the final answer must be negative because you're decreasing from left to right. So it's a quick check. Plus, number 4, there's no calculations. We don't even need to count, but it's a vertical line, which means it has no slope, okay? So we can say either no slope or empty set, okay? And we've talked about empty set means no solution, similar to no slope. But a 0 slope, don't confuse these, and we're going to talk more and more about these so that you truly understand a 0 slope versus a no slope, okay? They're completely different. As you can tell, a horizontal line is completely different from a vertical line. But now that we did, again, you can classify them quickly, and it's a good check to make sure that your final answer matches with what it should be. Okay, now let's talk about rise over run for a second. So go up here. If we know that slope equals rise over run, and we said rise was the vertical change. Well, vertically, we can go up if the numerator is positive, or we go down if the numerator number is negative, okay? Because vertical change means you can go up or down, okay? So if this numerator is positive, you go up. If the numerator is negative, you go down, okay? Now the run is the horizontal change. Remember we said this delta, this Greek letter delta means change. Well, we can only go left or right horizontally. So if it's positive, you're going to the right, just like your number lines. All the x's to the right are positive infinitely. Or you go left when the number in the denominator is negative, okay? We're only talking about the numbers in the denominator. Now, in class we talked about equivalent fractions. So we know you can have like a positive over a positive is equivalent to a negative over a negative, okay? Overall, and remember this fraction bar means division, that overall these two equivalent fractions gives you an overall positive slope, okay? So we're going to get used to writing these two in 2 different ways so that you can have the equivalent slope. And we also talked about same thing, if we had a positive in the numerator divided by a negative, that's going to be equivalent, even though we're going to go in different directions, to a negative over a positive, okay? And we know that overall, a negative divided by a positive or a positive divided by a negative means negative. And again, this negative means that the slope, you're going to have a negative slope. But these equivalent, these two are going to be equivalent, okay? And we're going to talk about that. Remember how I said to classify slope, you can only go left or right. But to count slope, you can go both directions. That's why we have two equivalent slopes. Now, I'll explain what that means in a second. This is a very important detail, even though it seems really elementary at this point, okay? So, like on this number 1, I'll start from these 2 points. I'll just use the points that they have marked. Even though we know there's an infinite number of points, I could probably choose anything that crosses the grid. Oh, and the light comes off. Okay. So on number 1, I'm going to count my rise, okay? Well, so if I draw a right triangle between these 2 points, the rise is the vertical. So if we count, we end up going up 1, 2, 3. Oh, by the way, a lot of people forget this. When you move, it's 1, not when you start. Wherever you start is counting as 0, then 1, 2, 3, 4, 5, 6, 7. So we had a rise was 7, okay? And since it's positive, we're going up, it's going to be positive 7. Then we go, so now that we stopped, we're changing direction, we're back to 0. Then we count 1, 2, 3, 4. So our run was 4 to the right, so that means it's positive. So, well, we know a positive over a positive still gives us a positive overall slope, so we're correct. And I would just, and I know this seems like trivial again, I'm emphasizing, at least for notes purposes, so you can refer back and understand that we got positive because we counted the rise separate from counting the run. But the overall slope, we didn't have to put a sign because we know without a sign it's positive. And 7/4, we want to keep it as an improper fraction. Because the definition is rise over run for slope, we don't want to, or we always want to keep it as an improper fraction or just a regular proper fraction, okay? It's okay to have slope as whole numbers. We'll talk more about that later. You'll just write the whole number over 1. And then you'll be able to read your rise and your run. Okay, so let me show you the negative slope, and I'm going to show you how to count it in both directions, okay? So if I draw the right triangle between these 2 points, I can see that I have to go down 3. So I go -3 in the numerator because remember, down means negative for the horizontal, or sorry, for the vertical change. Over, and then after I get here, remember I start at 0 and I count 1, 2, 3, 4, 5, 6, 7, 8, 9 horizontally to the right. And since it's to the right, it's a positive 9. And we know a negative divided by a negative is going to give us an overall negative slope, which is what we classified it as. We just have to remember to have that negative, okay? Now 3/9, we need to reduce. You always have your final answer reduced. So I'm just going to divide out 3 out of both, so we get a -1/3 slope. Now I'm going to show you, and again for notes purposes, this is really important to understand. I'm going to show you how you can count going to the left and up and still get a -1/3 slope. So let me show you. Like you could draw the box on top, okay? So from this point, if I start from the right going to the left, means I go up 3. So if I went up 3, the numerator is positive. Then I count 1, 2, 3, 4, 5, 6, 7, 8, 9 to the left, so it's -9. But we know a positive divided by negative is overall negative. And then if we just reduce it like we did before, we get the equivalent slope, which means the same slope whether you go left or right. So my point is, counting slope, as long as you understand the positives and negatives for the vertical change and the positive and negatives for the horizontal change. In other words, you're reading the numerator separate from the denominator, depending on which direction you're going. It doesn't matter which direction. And I want you to become efficient at both. But when you're classifying it, you only go left to right. So left to right only when you're classifying. And basically, if you're counting your slope correctly, your final answer will be exactly the classification it belongs. okay? Now, these two we already did, as long as you can either memorize it, and like I said, we're gonna come back to it. Just use your notes from now. The acronym we're gonna get for these two is gonna be really helpful. So let's count the slope for number 5 and 6. So I'm gonna use these 2 points again, and I'm gonna draw this triangle. So from this point I go up 1, 2, 3, 4, 5. So it's a positive 5 for the numerator. Then it's 1, 2, 3 to the right, and right is positive. Well, positive over positive is just positive, so it's 5/3, okay? Now again, that may seem trivial that I'm writing these separate. The point is I'm trying to make emphasis until you really truly understand the directions of the numerator and denominator separately and the simplifying after, okay? Now I could also use this other triangle. In other words, and I didn't really do that for this one, but here, if I went from the top point to the bottom, I would have to go down 1, 2, 3, 4, 5. That means it's a -5 for the vertical change, because I went down, it's negative. So as soon as I went down 5, then I'd have to go 1, 2, 3 left, which is -3. Well, we know a negative divided by negative is positive, so we end up getting the exact same final answer, and it's the same as what we classified it as going increasing from left to right. So my point is you can count any direction as long as you understand the positives and negatives for rise over run separately, and then you overall simplify it and it'll match the classification, okay? So now let me show you for number 6. So if I draw this triangle, we know from this point it's up 1, 2, so it's positive 2 for the numerator because that's vertical. Then 1, 2 to the right, which is also positive. But positive 2 over positive 2 is just 1. We simplify it to a whole number if it does simplify to a whole number, because that's the most simplified. Now again, remember I said you could do the other triangle also, which means I could start at the top point, which means if I go down 1, 2, that's -2. But then I'd have to go left 1, 2, which is also left is negative. But a -2 divided by a -2 is still positive 1. So either way, as long as I count correctly and have my correct sign for each direction, you're gonna get the same overall answer that matches your left to right classification or type, okay? Now, let's do a couple more, and then I want you to practice the rest on your own, okay? Or maybe I'll do like some smattered problems, okay? So if you look at number 7, if I go to these 2 points, now, okay, if you understand the 1 through 6 really well, you can pause it and go to the end to check and just do 7 through 21 on your own. But if you're still confused about this, I'm gonna go a little faster so that than I did with 1 through 6, so that it makes more sense. So maybe sometimes the slower explanation confuses people. So I'm just gonna draw the right triangle between the 2 points. So starting from the top point, I have to go down 1, 2, 3 for the vertical, which is the numerator, and then I go right 1, which is the denominator for the horizontal, and then all I do is, well, negative divided by a positive is negative. 3 over 1 I can just write as the integer -3. Now, I want you to practice both directions. Now let's start at the bottom point. If I draw that triangle, I have to go up 1, 2, 3. Well, up 3 is positive in the numerator, but I have to go left 1. Well, left 1 is -1 on the denominator, because that's your horizontal change. Well, positive divided by negative is negative. 3 over 1 is the integer, where we don't have to write it as a fraction. Okay. Now let's try number 11. So between these 2 points, remember, and the other thing that might confuse people too, like, let me use this point. So if I call this point A and this second point B, if I wanted to get the coordinates for point A, I would have the x is -2, and the y is positive 3, because we know that quadrant 2, the x's are negative and the y's are positive. And the reason why I'm explaining this, so points start with x and then y, but slope starts with a change. Remember we said delta means change in y, because y's are vertical, over the change in x. So it's opposite. Slope, you always do the y's first, the y's are on the numerator, over the x's, which is opposite of what we do for points when we do the coordinates. Because on coordinates of points, we do the x first and then the y. So these are completely opposite order. That's something you really need to understand, okay? And at first it might be confusing, but keep reminding yourself that when we're counting our slope, we do the y's first, then the x. Not like our coordinates, where we do the x first and then the y, okay? So number 11, between these 2 points, if I draw the right triangle above it, I have to go up 1, so positive 1 for our vertical, and 1, 2, 3, positive 3 to the right. Well, that just gives me a positive 1/3 slope. If I go the other direction, just to prove that I'm not only mastering both directions, but I'm going to get the same answer in the end, so that all my work matches. So if I start from the top point and go to the bottom point, I have to go down 1, which means it's a -1 vertical change, and go right 1, 2, 3, which is left. Oh, did I say right? You go down 1 and left 1, 2, 3. And we know left is negative. Well, a negative divided by a negative we know is positive 1/3. And actually, we don't even need to write the positive. So the slope is 1/3, okay? Now let's look at number 15. Again, if this is starting to make sense, go ahead and stop and then come back and check if you are counting your slope correctly. So number 15, if I draw the right triangle between those points, if I start at the top point, I have to go down 1, 2, 3, 4, 5, so that's -5 in the numerator, right 1, so that's a positive 1. Well, we know a negative divided by a positive is negative, and 5/1 is just, we don't need to write it as over 1, so the slope is an integer 5. Now we can go the other direction. So if I start at the bottom point, I have to go up 1, 2, 3, 4, 5 for the vertical, and left 1, which is -1 for the horizontal. And again, positive divided by negative is also overall positive, or sorry, a positive divided by negative is also overall negative, and 5/1 we can just write, we don't need the over 1. So either direction, as long as we get our signs correct, we get the same answer. And it should make sense because it's decreasing from left to right, so the final answer should be a negative slope. So I'm actually going to pause. I want you to do the problems that I didn't do and then see